Alright, what are we doing again?
Complex batching.
Current goal.
Okay, so do
X.
you remember what the question was? So let's see, it
The
was.
cyclic pentagon. AB equals to AE equals to C.
Oh yes.
Yeah.
How could I forget?
And then you set up some random points. H is like, no, not, yeah, don't use H for the something.
Okay, so you have a circle, yeah?
Yeah.
And then you have like A,
Huh?
It didn't use H.
B,
Don't use H for the ortho center. Because, like, why not? Use like E or something.
Wait, what about the cyclic pentagon?
Huh?
Is it A, B, C, D, E?
Yeah, you see.
I hope this ends up working. Okay, so it's C and D, yeah, and then E.
Your ortho center might be like off the board. Because you find the ortho center
Yeah. Yeah.
uh,
I guess this is why we ended up complex patching.
Draw a mini diagram. Wait, and then what do you...
Okay, so the conditions were that this length
AE
is equal there, right?
Yep. And
This
C
length equals that.
Yep.
Yep.
Well, not arc lengths. Oh,
The
so same thing.
Same thing, yeah. The chord lengths. And then we had this other condition with the midpoints of B and
The
C,
midpoints
right?
of B, C, and E, D, like I and J.
Yeah, so the one of them's I, one of them's J. But I don't think it actually matters.
Yeah,
Because-
B, C would be I.
So then there was a G, right? There's like an O somewhere here.
O is just the center.
And then there's a triangle here.
Yep.
So F is the orthocenter of AEB, yeah?
Yep. And then G is the. What is G? Is that the in center? Is it centroid?
Yeah, G is the centroid
G is the centroid,
of
yeah.
AIJ.
Yeah.
Where's
It's the
that?
star of David.
Oh.
Maybe here.
Yeah, G is
Yeah. And then
fourth
you find
center of... Okay. Where?
G is the centroid of
Centroid,
AIJ,
yeah.
and F is the orthocenter. And then you
Where-
find the
where-
intersection of
Or F is also center of A, I, J.
A, B, E.
A, B, okay.
Yeah.
This is O is the circumcenter. The
Yeah.
actual
And
center.
then you find the intersection of B, D, and C.
Oh, that's right. Okay, so
I think it was B.
so we want to how we have an M, right? There was an M, so it was A. Yeah, so F. Oh yeah, that's right. Okay, so E.
and OG intersect at some point. If
Yeah,
it
so
was
like-
A, that point is probably.
So here intersects at H, right?
Yeah.
And then H intersects OG, yeah, with FH.
Yeah.
So FH.
OG intersects. Yeah, and show that AM.
So this is M, right?
To CD.
With them.
What?
M is the intersection of
It's the
OG and FH.
You prove
That was
AM.
F.
Huh? F is the orthocenter of, so F equals the orthocenter of ABE.
Let's see it.
Yeah, you just do it.
Okay, easy.
Easy. And you prove that AM is perpendicular to CD.
Oh yeah, and the actual question, yeah. So
Yeah.
AM is meant to be
Perpendicular to CD.
perpendicular to CD, yeah.
Yeah, it's.
Okay, so when I saw this question, like I don't have any experience complex batching. Okay,
Yeah.
I don't pretend to. But when I saw this question, it looked a lot like the stuff that we would complex batching in that worksheet. Okay. And I was determined to complex batch this. Okay. To my disappointment, okay. So what I expected of complex batching was that I labeled all the variables, make all the choices I need to make at the start,
Yeah.
and then I would just be able to get to the answer without thinking. Okay. This was obviously naive, despite all my experience. It's like, yeah, and I realized I probably shouldn't even thought that. It's like, why would, like, even in like routine calculations, lots of like thinking actually helps routine calculations a lot as well. So what I ended up getting was like this hybrid, which started off as a complex batch and ended up as like a trivial geometry problem.
Oh, right.
Yeah, so it's kind
so
of.
Did it wasn't actually...
Oh, you got it?
Oh, no, like
No.
for the other question.
Oh, okay.
Or would it treat the bash?
Yeah. So do you ever like you feel like you, every time you could do the chord bash? I don't know. Like, does it feel like you're always more clever than you should have had to be? Like it's like, oh, I had to be more clever
I
than
never
I.
learned how to bash, so I never tried.
I never, I just, it started, like,
Just started telling me.
I started...
Okay. Do you know about complex numbers?
Yeah.
Okay, so part of it. So one of the things that we know, I don't know if you know, like, it's like one of the lemmas we learned was the author center is the sum. Like if we make the circle the unit circle,
Yeah.
okay, then the 3 points on the unit circle, the author center is given by like a plus b plus c. Like it's like in this case it's a plus b plus e.
Oh,
So that's
Can you
like
prove it?
a nice result.
can you prove it?
Sure.
Do you know it? Do you want to prove it?
Should you try?
Yeah. Okay. So basically
Yeah.
it's basically because a, b, and e they're all
No,
they're all unit vectors, right?
What?
Yeah.
Yeah.
Isn't that
Yeah.
a way to do it without using vectors? Like just normal geometry?
Yeah. This is trivial. Yeah. So you have like so like what do you call it? So basically, if you have a plus b plus c, right? Let's just forget that for now. A plus b plus c, and you want to show that that's the author center, right? Then the vector that's like ah, right, is equal to this minus a. Yeah. Like the vector ah is, if we're pretending this is h, yeah.
Aren't you proving it's H?
No. Okay. Basically we're checking that it's the author center. We're not really figuring out why it's the author center.
So
But like,
aha, you did prove it.
no, we did prove it. But we know the answer, so we're just gonna check the
There's only
answer.
1 point and we reverse.
So we're basically what we're trying to do, right,
Yeah.
is check that AH is perpendicular to BC. Yeah?
Right, yeah.
And then obviously switch around the ABCs.
Yeah.
Okay?
There's a perfect.
But what AH would be here is it just be B plus C, right?
Yeah.
Yeah?
Yeah.
And then we're just showing that B plus C is perpendicular to B minus C, right?
Mm-hmm.
Because that's what BC is.
Yeah.
Yeah.
Yeah? So if you have like 0, this is B, this is C, right?
Yeah. Oh.
Yeah.
Yeah? This is also C, yeah?
Yeah.
Yeah.
This is also B, yeah?
Yeah. So it's B.
Yeah.
So this is B plus C, yeah?
Yeah.
Yeah.
And this is which one's B minus C?
B minus C.
Head minus tail.
Yeah.
Is that one, right?
Yeah. But wait. Is that?
Doesn't matter where the arrow.
Oh.
It shouldn't matter which way the arrow goes.
Okay.
Yeah, it doesn't matter which way it goes. So
Vectors are direction.
the point is, because C and B are the same length, right?
Yeah. So
That parallelogram's a rhombus. Yeah?
Right, C and
Wait,
B
why
are-
are B and unicircle?
They're on the unit circle, so they have the same length, right?
So if it's on unicircle, then
Yeah.
it's,
So because it's a parallelogram normally, now it's a rhombus.
There's
Wait,
no
that's
square.
that.
I don't think it's. You can't say it's a square. You don't know where they are.
Yeah. Rhombus and so rhombus. That.
But there's basically a 90 degrees in the middle.
Alright, yeah.
Yeah.
Okay.
So that proves that H is the author center, basically. Yeah. Okay.
And same thing for every other side.
Yeah. So, well, the funny thing was, okay, so we need to figure out not just the author. Oh, what am I erasing? It's not just the author center we need, right? We also need the centroid, yeah.
Yeah.
But what's kind of funny is that, like, if you look at it, it looks like, oh, wait a minute, I can't do that here because the centroid is not for a triangle that's on the circle, right? Remember? Remember how we stated the theorem? It was like 3 points on a circle,
Uh-huh.
the unit circle. The centroid, so basically, we're saying f is equal to a plus b plus e, right?
Yeah.
Yeah. So that's the centroid of a, b, e. Oh, and it's I guess it's standard to use little letters to denote the big letters. So the complex number little a, little b, little e, and so on. Yeah.
Yeah.
Okay. So the theorem that we had was that the centroid of AJI, right, was a third A plus I plus J. You remember that?
That's not a
Yeah.
unit circle.
Yeah.
Huh?
That's not a unit circle.
Yeah, so the theorem only stated it for the unit circle, but it actually works for any triangle. Yeah? So what is it?
Seems like it.
Excuse me, I thought that was my line.
Excuse me, I'm unique in every way that I am.
I'm black. Crap. I'm black, I'm Soviet, and I'm also Nazi. I'm unique.
Okay.
Yes.
So central is just A plus B plus C over C.
Yeah, so
right?
here's the psychological part of the training. If you get through the maths, but if you can't get through it while being trolled constantly and distracted, then you're not good to us.
Oh, it makes sense in the unit circle because the centroid, also center, and center, and the center.
Oh, they're on the same line.
Yeah.
Yeah. The Euler line, yeah. But I think even without the unit circle, it's still like a third of the vectors.
I think that's how it is for cold battery as well. So,
Yeah.
because it's like the gravity center. So
Yeah, because
Yeah.
we had like
Oh yeah.
So if you just do it, like I mean, what are you showing? Like if you know that's what you're trying to show, right?
Yeah.
Then you're basically kind of showing like, you know, the distance is in the ratio 2:1 kind of thing, right?
Yeah.
That'd be enough. Maybe I'll show you in another way that that'll help me do the next thing, okay? So if you have like I didn't like these letters. Can we go back to ABC? Okay, so we go back to ABC. If we have like A, maybe that should be a big A, and then this is the midpoint, right? The equation of that line, right,
What's the midpoint minus A?
is the midpoint minus. So it's A plus a multiple of the midpoint minus A, yeah. Like the vector equation. Of this one.
Yeah.
Does that make sense?
Oh, multiple.
B plus C on 2 minus A.
Why is it
So
not-
this is we call this M, right? So this is AM, yeah,
Okay,
and then this is OA, yeah.
Okay.
So I mean, if lambda's 0, then you got that point, right?
Yep. And
If lambda's somewhere in between, all the way up to 1, you get to
one is at hand.
then you get to B plus C on 2, right?
yeah.
So basically, for every real value of lambda, you get a point on the line AM.
Yeah.
Okay.
Does that make sense?
And it intersects at the
Yeah, so if you take that idea, right, and you have like B plus mu, and it's A plus C on 2, right, minus B.
Yep.
That's another median, yeah.
C plus mu.
C plus nu, yeah.
Just use V, right?
So it's A plus B on 2, yeah,
Yeah.
minus C, yeah.
V plus omicron.
Yeah. Is that right? So there should be.
And
A
then there's
value.
only one solution.
Yeah, so if you set lambda, mu, and nu,
Yeah.
so basically, if you can set them to one value, like not to the same value, but if there's one value of like what that, and this, and that, such that all the points give you the same expression, that must be an intersection,
Yeah.
right?
And just
So I think if you set them all to 2/3,
2/3, yeah.
right?
Yeah.
If you 2/3, you get you
You
get a third, you get a
Yeah, 1/3 of.
you get a third of everything, right?
Yeah, yeah.
And that's what the answer is, isn't it?
Yeah.
Okay. So that's the centroid taken care of, and it doesn't have to be unit vectors, as you know with chord batch, right? Okay. So that's something is kind of annoying because you have to figure that out as you do it.
And then for 1/3. For central.
For cold batch.
Yeah.
You just sum the x values, and you sum the y values. And
Divide by
take the
three.
averages, yeah.
Okay, yeah.
Yeah. So
Alright.
so you can obviously like if you run into this, it'll take you longer to do, right? So like it's better to have some idea of these before you go into it
Yeah.
exam wise. But pure maths, I mean, if you run into a problem, you have to solve it, yeah.
Yeah.
And one of the problems was actually just the presentation of our theorems. It was just like they were all presented under the same assumption, which doesn't need to be held here.
Yeah.
Okay, all right. So the thing works. So that's G, yeah. Okay.
Yeah.
And also you might want to notice that it doesn't have to actually be G. Any multiple of G will suffice for our purposes, right? Because we only need the intersection of OG, yeah. We only care about the line OG,
Oh yeah.
so we can
So
scale it
any-
as much as we
yeah.
like.
Yeah.
It doesn't really make a difference, yeah.
But it has to lie on that.
Yeah. So I don't think M even like necessarily goes between O and G, you know? It could
So
either-
1/3, you don't need the 1/3.
yeah, it doesn't have to be 1/3. It could be like 2/3. It could be 1/6.
It could be the also center.
Yeah, so that's going to be interesting later on, okay? Alright. It's like, how could that possibly be interesting? Alright, and then, so this is the part where we might have to skip some things. So like, the part that we have to skip some stuff is the formula for the intersection of two lines.
Oh yeah. Okay.
You remember what that was?
Yes.
Huh?
No. It's like big and scary.
So I'm gonna give you an idea how to prove it, but like it's
Yeah.
gonna take us too much time, and like it's not quality time.
Okay.
So I'll prove the easy case, and I'll leave the hard case, the maybe not hard, but the long case, to your private study.
CD times A plus B minus AB times C plus D.
Okay, so let's try to not. Yeah, like don't use. Let's substitute the letters before they confuse us. Okay.
Okay.
So it was, you had two lines.
On the units.
So it didn't have to be on the unit circle, but when it's on the unit circle, it simplifies a lot. Yeah.
Yeah.
Oh, you worked it out when it's on the unit circle.
Yeah.
Can you tell us what it is?
CD times A plus B. Minus
yeah.
AB times C plus D. On CD
So let's do it. C
D
D
times A plus B.
times A plus B.
Yeah, in brackets. CD bracket A plus B.
Maybe we can. Do you have the general one? Because if you don't know why it specializes, it might be easier just to
Oh,
specialize.
specialize is because.
Because we need to specialize it twice. So we need it for H, right? And we need it for M.
So
Yeah.
A bar minus A bar B minus A B bar
A bar B minus A B bar. Yeah.
in brackets minus. Oh wait, there we
This is A B intersect B C. Yeah.
Yep.
C D.
Minus A minus B C bar minus C bar D minus C D bar in brackets on A bar minus B bar times C D minus minus no, A bar minus B bar minus C minus D minus
C minus D. Yeah.
minus A
And
minus
then
B.
it's A minus B C bar
yeah.
minus D bar. Yeah.
Now to find out where we got this.
What's bar?
Huh?
Conjugate.
Complex conjugate.
Alright.
Yeah.
How do complex conjugates even work? Other than the fact that just do fractions across the x-axis.
That's it.
Yeah, that's what it is.
Yeah, but how do you get arrive at these results?
Huh?
How do you even arrive at these
Yeah, so
results?
I'll explain it to you, okay? So basically what I want you to do now, okay? Specialize, so like you don't even have to actually sub in what G is, okay? But just pretend like one of them is OG and the other one is, so just use the letters little f and little h, yeah?
Okay.
And 0 and little g, yeah? And sub it into here. Does that make sense? So that's what M will be, right?
Yeah.
You just change the C to like 0.
Yeah, C or D. I think D was, yeah, it makes no difference. Maybe we can do D equals 0, okay?
Oh yeah, D. So
Okay.
So what is that?
Wait, we're setting D equals 0 and finding H.
we have FHs A
Yeah.
and B.
We're just using the letters little f, little h, and little g, yeah? We're not subbing them in, yeah?
So
Okay.
F bar.
We're not subbing what they are in, we're subbing the letters in.
Yeah.
F bar H
F bar h, yep.
minus FH bar.
Yep.
Minus F minus H.
Wait a minute, there should be... Wait, there should be a C minus... Is there something here? C minus D?
What's that?
Yeah, that's
Is that the 1% one?
F is D.
There's something missing
no,
here.
there's no.
Okay.
There's nothing here? No.
Oh, there is C minus.
There's something here.
There's C minus D. Okay.
C minus D?
Yeah, C minus D.
That'll make it symmetrical.
Yeah, I think it should be symmetrical, right? Because there's no...
No, it's not.
Okay, so C minus D is just G, right?
Yeah.
Yeah?
Yeah.
And the next one comes.
Minus. Wait. What? Yeah.
Then these are all zeros, right?
Yeah, these are all zeros.
And then this is just
F bar minus.
How do you even get
bar.
G what?
F bar
minus
H bar, right?
Yeah.
G minus F minus H G bar, yeah?
Yeah. G bar. Yeah.
I mean, I've done this before, so this does check out, okay?
How do you even get this?
Yeah, so let's just try and prove this directly, yeah? You get some idea where the bars come from at least, yeah?
Okay.
Because that's pretty much one of the main mysteries, yeah?
Yeah.
Okay, so consider, so is it obvious to you that
No.
M from this formula is on OG? Is that obvious?
Well, yeah, so it's it's some scale of G.
Yeah, see, because can you see,
Yeah, it sounds.
can you see F bar H is the conjugate of FH bar?
Yeah.
Yeah? So then if you something minus its bar, it's imaginary, right?
It's the imaginary thing.
Yes.
Yes.
Okay? The bottom thing is also something minus its bar, right?
Yeah, so it's also imaginary.
It's
so
also
real.
imaginary.
So it's just
Okay.
real.
So then when you cancel the i's, there it's a real multiple of G, yeah?
Yeah.
Okay.
So it's actually on OG.
So it's a real scale of
Yeah. But to make it less mysterious, and this I think will explain the other formula as well, yeah? Is if you just think of what I was doing with the lambdas, remember?
Yeah.
So what was I doing with the lambdas? So you have like lambda, yeah, lambda G, right? That's what a multiple of G is, yeah?
And
Is equal to, and then we're looking at, well, it's either AB or FH, right? So let's do FH, so it'll be like F plus a multiple
of F minus.
of
H
F, F minus,
Is it H minus F?
H minus F, yeah?
Yeah.
Does that make sense?
Yeah.
So
So that's the.
that's like the intersection condition, yeah?
Yeah.
Yeah.
Okay. So it looks kind of weird because it's got like, you've got two variables, right? Lambda and mu,
Yeah.
and you have one equation, right?
Yeah.
But in complex numbers, every time you have one equation, it's really two equations. Because it's imaginary and real, right? So complex numbers have two numbers in them.
Yeah.
Yeah? So, and what is imaginary? What is real, right? Real is just x plus x bar,
Yeah.
Oh. you know, times
Oh.
half, yeah? And imaginary is x minus x bar,
Yeah.
yeah? So that's where the bars are coming from, yeah?
Okay.
So basically you're just solving this equation simultaneously in real and imaginary parts.
Yeah.
Does that make sense?
Yeah.
Do you want to go through it?
Yeah.
Yeah? Okay. I wrote it here, see? It's actually pretty simple. It's just doesn't necessarily translate simply on written. Yeah, so if you take the real part, right?
Yeah.
It's real F plus mu real H minus F equals lambda real G, right?
Yeah.
Okay. You take imaginary, yeah? Equals lambda imaginary G, yeah?
Yeah.
And now it's just actually two simultaneous equations, right? This is just real. Everything's real now. Right, so basically you're just solving for mu and lambda in terms of
The
real f's and like everything else in there, right? But if we only want this formula, right, we really just need to, so we can target lambda, right? This is going to be lambda. Because like m equals lambda g.
Yeah.
So if we find lambda, we don't have to sub back to find mu, yeah? Yeah, so how would you solve your favorite, like what's your favorite way of solving a simultaneous equation? I think if we wanted to find the lambda, right, we would try to get these mu's to cancel. I feel awkward even saying this. So, you know, times the first one by that thing.
Yeah.
It's like two steps, yeah?
Yeah.
You agree?
Yeah.
Okay. And then after the two steps, you just sub in h minus f bar to get the real and the imaginary parts.
Oh.
Do you want me to go through this?
Yeah. So
Okay, I just need to like allocate my space here. Okay, so this is real f, imaginary h minus f, yeah? So times the first thing by imaginary h minus f. Okay. So you get plus mu something equals lambda real g imaginary h minus f, yeah?
Okay.
And then you times the second thing by real h minus f.
Okay. Yeah.
So you get imaginary f real h minus f plus mu. It's the same thing times mu, right?
Mm-hmm.
The whole point of doing that. Lambda imaginary g imaginary h minus f, yeah? Yep. Okay, so then you cancel, yeah? So you get lambda equals, so let's do the second one minus the first one, yeah? Oh, did I do the second one minus the first one? I did the first one minus the second one. Alright, so the first one minus the second one, you get real
minus.
real g imaginary h minus f, yeah? Minus imaginary g real h minus f. Yeah?
Yeah.
And then the other things were real f
Oh, and that's how you did it.
imaginary h minus f minus minus, what am I up to? Wait, did I do it the wrong way around? I think so. Imaginary f. I'm doing 1 minus 2, yeah?
Yeah.
So it's imaginary, wait, what is 1? 1's this one. Sorry. Minus imaginary f
Okay.
real h minus f, yeah?
Yeah.
Okay.
Oh.
So, I mean, now we just,
Wait, you're missing. Wait, imaginary real. What's the one bottom one?
this one,
Yeah.
imaginary g,
Oh,
Okay.
yeah? So, I don't know, maybe we can do this in pieces. So, the bottom thing is, so the denominator, right, is g plus g bar, yeah? We don't have to do the halves because they all cancel anyway, right?
Mm.
They cancel with the top halves
Yeah.
and each other. So g plus g bar, and then we have h minus f minus h bar minus f bar, yeah? Minus, this would be like probably better to just do yourself, but anyway, so this is g minus g bar h minus f plus h minus f bar, yeah? Maybe this is the kind of thing you need company to do. So I remember we have like, in grad school we had like marking parties where we'd get together to mark stuff. Because it's just kind of too boring to do by yourself. Okay, so like the coefficient of g, right, should be f bar minus h bar.
Yeah.
Yeah? So here it's, where's the thing that cancels?
It's the
Yeah, the h minus f cancels, right?
which one is that cancelled?
Because it's h minus f times g, yeah? And it's h minus f times g here,
Yeah.
and they cancel.
Yeah. And then you're left with
Yeah.
Then you're left with,
H it's minus.
so negative of h bar minus
so
f bar,
that's
right?
F bar minus H bar. Yeah.
So it's f bar minus h bar times 2, because there's another one there,
yeah,
right?
absolutely, yeah.
But the 2 will cancel eventually.
Yeah, somewhere.
Okay? And then the coefficient of g bar, yeah, it should be f minus h, or negative f minus h.
Okay.
Okay, and so here it's this other thing that cancels now, right? Because that's a minus and that's a plus.
Yeah.
Yeah?
Yeah.
So then you get the two H minus F's.
Yeah, and that's the.
And that will cancel.
the two
Yeah.
And then it's a
Yeah, H minus F is minus F minus H,
Yeah.
right?
Yeah.
Okay, so basically we got 2 times the denominator, yeah?
Yes, and then
Yeah.
we'll probably also get
Oh.
the
Actually,
numerator.
we got the halves actually, don't we? We didn't do the halves, so the half cancels with itself.
Oh, yeah. So now we just have the denominator.
Oh, yeah, I'm confused now. There's like a
Um,
half
so-
here, but there's still a half. Okay, so
Yeah.
don't worry, it's gonna be the same for everything, okay?
Yeah.
Okay.
And then it should be fine.
The top should be well, should
I
do
hope.
the things, yeah, stuff happens. Yes.
Yeah. So, but the thing is, now you've explained the mystery of the bars, yeah?
Mm.
Yeah.
Should we go through the top?
No.
No, this is good.
Okay, good.
Yeah.
Wait, don't
Thank
do
you.
not.
Huh?
Oh,
Huh?
okay, I didn't say anything.
Okay.
Okay.
You just convinced it'll work,
Yeah.
and it's actually not as hard, okay? I mean, after a test and lunch and stuff, it seems hard. But like, this stuff is, you can do this without looking, yeah?
Oh.
Okay.
Like, there's no thinking required. This is the kind of thing I hoped the whole problem was gonna be,
Oh, okay.
right?
Okay.
There's no thinking involved in this, yeah?
Yes.
Yeah.
It's routine. Like, there's no way, like, you'd
Yeah.
think I would not solve this if I tried. Yeah, that's the kind of impression I want you to have.
Okay.
Otherwise, we might have to do something.
Mm.
Okay, and the same with this, right? Can you see this is just this like a
Yeah.
more chunky version of that, right?
Yeah.
It's more,
Okay.
Yeah.
So as long as you're convinced. So obviously the problem is being convinced doesn't necessarily make this formula as written true, right? Okay. Okay. All right. Okay.
Alright, hang on, what happened to the mu in the
You cancelled it.
cancel the mu?
Yeah,
Oh.
because they multiply
Yeah.
it
So
by
we
the-
multiply
and then
Oh,
measure it.
yeah.
Yeah, we can find mu later if you sub it back in. Yeah.
Okay.
Okay, so then there's one more thing is, even in the notes it was like this equation is not going to really help you, unless you're doing this special case here, or like A, B, C, D are all on the unit circle.
Oh.
Yeah. So that's the case when you have E, B, C, D, right?
Yeah.
So what happens when they're all in the unit circle? Well, the point is the B bar
So
B
bar-
bar
B
is
bar
turns into B inverse.
Because
Yeah.
because
The inverse is
they multiply to
Because B times B bar is equal to 1, right?
Yeah.
Because it's equal to the absolute value of B squared.
Oh yeah.
Yeah, and it's on the unit circle.
Yeah.
So then, B bar becomes 1 on B. So then getting rid of all the bars is just like clearing denominators. It's times everything by... So maybe we can write that down.
by A, B, C.
So what are we doing? We're doing E, B... What are we doing? We're doing E... So EC intersect BD, right?
Yeah. EC.
Yeah. So I think, yeah. So EC intersect BD. So I'll write down what it should be from this and then I'll erase, yeah? So EC. So EC. So E bar. C, yeah?
Oh, I have the simpler version for you.
Oh, do you? Okay, we use that to check just in case. EC bar, yeah? And then BD, B minus D. Did I write this down somewhere? I must have written this down somewhere. No. Maybe I can just cut to the chase and then you can tell me if it's right, yeah? So, I had CE D plus B minus BD
Yep, correct. Well, everything right.
E plus C over, so this is H, yeah? Is equal to CE minus BD. So all I did was put, those letters into here and then cancel out as, like, when you put A as A1 on A,
You cancel
and then times by, like, make sure all the denominators, times by all the denominators, and then you get some differences of squares that cancels. But it's all routine, yeah?
Oh, you good.
With this, yeah, it goes down.
It goes down. Okay. I'll trust your word. Yeah.
Okay, well, I'm glad we got past that. Okay.
Time to stop the question.
Yeah, don't just... Yeah, that was the theory part, yeah?
No.
So I guess you meant to go into it with that. So,
Yes.
but if you didn't go into it with that, then your first 36 minutes will be about that.
Alright.
But like, it's possible. See, that's kind of like maths. You always get a chance. Okay. Yeah, and you might not take 36 minutes, depending on. Okay. So we're convinced we can kind of find expressions for all the variables now, right?
Yeah.
Because what do we have? The intersection, midpoint. Midpoint is obviously just average, yeah?
Yeah.
And we have... So this is where I got a bit stuck at first. So it's obvious where I'm going to put the circle in this problem, yeah? I pick the origin. I make the scale unit, okay? So the other choice, it wasn't too obvious, like where to put the real axis, yeah? I don't know, where would you put it? Yeah, so the things that I got stuck on, I got stuck on putting the real axis somewhere, right? Even though I had like things I could put the real axis there, and then I kind of got stuck on like how to use the condition, like because we haven't done all the conditions yet, right? Because at the moment there's 5 variables. Yeah, like everything comes from 5 variables. So we haven't got the real axis and we haven't got the conditions. Yeah. So, any ideas? By the way, I was so naive. I was like bashing it before I even did those things. Okay, that's how dumb I was. But yeah, Sean. Yeah, we're looking for the real axis and we're looking for the conditions. Yeah.
Make DC like one of the axes, I guess. Because
DC.
you're trying to prove it's perpendicular.
Oh yeah, and then like make it kind of like. Okay, then you're proving it's just imaginary, right?
Yeah.
Okay. Probably could.
Yeah, probably make A more CG, more black.
Anyone coming up with ideas like put A, B, or E or something equals to 1?
A, B, or C. Oh, yeah, I guess that works. Put A is equal to 1 and then E and B are
Conjugates.
conjugates.
Yeah, so basically, if you put a equals 1, you lose 2 variables, right? I mean, you should always lose about the same number of variables. There's some, actually, like, can you know that, like, because of these 3 chords are being equal, like, this line is, like, parallel to some of the line. Like, AC is parallel to ED,
Yeah.
and
Yeah.
AC, AD is parallel to BC. Yeah. So, like, I guess I would lean towards making A1 because the others would disrupt that kind of symmetry. Yeah.
And then, yeah.
Okay. And here's the moment where I was like, okay, this problem is complex bashed. Okay.
Oh.
This is the moment I was like, it took me so long to realize that once you make A equals 1, right?
Yeah.
Then B becomes, so E becomes B bar, right?
Yeah.
Okay.
You're trying to.
And then it's this condition I couldn't use. Yeah. Yeah.
Yeah.
But in complex numbers, okay, D is equal to CB.
CB. Wait.
So if you can internalize this right now, it'll save you a lot of grief.
Why is D equal
D equals to C.
See, because this length is the same, right?
Yeah.
So D is just a rotation by that much.
Yeah.
See, because A is 1, right?
Oh.
A is 1, then B is the number that rotates. You know complex numbers?
Not really.
So complex numbers.
Oh, B is the rotation of that.
So
Okay.
if complex numbers is like if you multiply a complex number by another complex number,
You get
the length is the product of the lengths, and the angle is the sum of the angles.
No,
You know that?
no.
No,
We can't. Now I do.
Okay. Okay. So.
Oh yeah, so the angle is the same. So it's just it's CB. CB.
Yeah. Have you seen this notation like EI theta?
Yeah.
Well, only in Euler's identity.
Yeah.
Yeah.
So the point of this notation is like E times I theta I like some other letter, right?
It's like
Say phi, right?
Yeah.
You get E I theta plus phi. So the angle adds, yeah?
Okay.
So if A is 1, the angle is 0 here, yeah?
Yeah.
And the angle here is, like negative whatever,
Yeah.
And so if you times something by B, it'll rotate it by that. It's like, say there's negative 30 degrees, right?
Yeah.
It'll rotate it clockwise by 30 degrees.
Yeah.
Yeah?
Yeah.
So that's what you want to do to C, right?
Yeah. Okay.
So then D, so this is this is like a punchline. D equals BC.
Yeah.
Yeah.
why is it?
Huh?
Why'd you rotate it by C?
You're rotating C by B. So you rotate C by this length.
Oh.
Yeah. It's like. So I went to sleep at this point. Yeah, I was a bit overconfident, but like. I mean, there's something like elegant about using all the conditions in the question, and something probably essentially like incomplete. Like you can't even do the problem if you don't. So like once you overcome that, it's like oh. So now we only actually have like 2 variables and like a 1. Yeah? Don't have a D anymore, don't have an E, and A is 1. Yeah?
Yeah. So we only have B and C now, technically.
Yeah.
Okay, nice. So, and then we can find
Yeah.
other stuff.
And you can't really get rid of C because C can really be anywhere.
C can be anywhere, yeah. And then so now we just bash using the conditions.
Yeah, and I was kind of disappointed that it didn't work for me. Like,
really?
it just,
Oh.
Oh,
but along the way, you can pick up little bits and pieces that solve the problem. And those little bits and pieces are not necessarily easy to see on their own.
Oh,
Does that make sense?
Okay.
So,
So
for
you-
example,
these make the problem easy. And then
yeah, let's see. So, So I was always a bit unhappy with G, yeah?
Yeah.
'Cause G is like this random centroid thing that makes me like have to think about the conditions of the theorem.
Yeah.
Yeah. So what was G? G is
G is
a third. A plus
B minus C on.
B plus, yeah, I mean it's the sum of the things on
Where
two,
the
right?
sum isn't the where was it the sum?
So
Because you find
E
that
plus D is J, right?
E plus D
On
on
two is J,
and B plus C
and B
is
plus
I.
D, yeah.
Yeah.
Okay. So you might notice from here, if you make this on 6, since we don't care about the scale, right?
Yeah.
You can make this on 6 and you get this 2A, right?
Mm-hmm.
Oh, actually, maybe you just keep it on 2 anyway. But like,
Okay.
what am I doing? No, maybe it was the same before. Anyway, like if you look at it like this, right?
Yeah.
Okay, what could that remind you of? Well, we know that the orthocenter, right,
Mm-hmm.
is the sum of the 3 things, yeah?
Yeah.
Can you see that this is the sum of 6 things?
Yeah.
Yeah.
Oh, A B C and
It's A, B, C, and A, D, E, right?
Yeah.
So that's kind of key. Or
Or it's
A, D, C, right?
A D C. Yeah.
And
And
A,
A,
B,
B.
E.
Yeah. Oh, and that's the one's the.
Yeah, that's
Yeah, so
yeah,
that's,
one F and the other one.
yeah. So the reason, like I don't know if you're meant to see that or whatever, but like, if you do see that, okay, then you immediately kind of know that something interesting is coming from this, because the orthocenter of ADC is a key character in this problem, yeah?
Yeah.
Because for A to be perpendicular to DC, it has to pass through the orthocenter,
Yeah.
yeah?
Yeah.
So wherever it is, you know, it's probably like it has to be like in line, right?
Yeah.
HADC. Okay. So maybe we do want to take it on 2, right?
Mm-hmm.
And think of it as the midpoint of the
Okay.
2 orthocenters.
Oh.
Does that make sense?
Yeah.
Because that's actually a thing. I mean, if you add them, it's not really a thing.
Yeah.
I don't know. Maybe if you knew what adding them meant, then you could think about adding them. But I understand midpoints, so I think about the midpoint. And things like that, it doesn't matter how you scale it. You could just make it half, right? So half midpoint of so you can basically pick G to be the midpoint of F and the orthocenter, the 2 orthocenters. Yeah.
Mm.
Okay.
Yeah.
So G equals midpoint of H, A, D, C, and F. Yeah.
Yeah.
Okay. Okay. Oh, by the way, there's obviously lots of stuff to do as well, right? Because I mean, E shouldn't be in there, D shouldn't be in there,
Yeah.
A shouldn't. Well, A is not in there. Because at this point, you just want me to do it, right?
Yeah.
Okay. Well, let's see if I just write you the answer for what happens when you simplify that.
Yeah, it's true.
Well,
Where did you get
oh yeah, this also helps actually. Like if you simplify this, okay, you get this equals B outside of C plus BC plus 1 on 1 plus B plus B squared.
Okay.
So this is what you get if you put, huh?
Replacing everything with B.
Oh, because E is. Oh, okay.
Do you want to go through it?
Uh,
It's about 6 lines.
Oh no, anything. It's like minus BC. Yeah.
I mean, if you're doing it yourself, you wouldn't really think twice.
Uh-huh.
Maybe it's important to notice that.
Okay.
So the only thing you had to notice was that like there was sort of like a factor of b minus 1 in the numerator,
Yeah.
and it cancelled out with b cubed minus 1 in the denominator at some point.
Okay.
Okay? And you get that, okay?
Mhm.
And this is part of this whole thing, because what is 1 plus c plus bc, right?
It's A B D.
1 plus b.
The centroid of AB.
Yeah, so maybe that'll explain. Yeah, so this d is bc, right?
Yeah.
Yeah.
C is
and C is C.
C is C.
Centroid of A.
And 1 is A, right?
One is A,
So that is the
that's
orthocenter of
the
A
orthocenter, yeah.
dc, yeah?
Oh.
Okay. And what's this other term here? If you think of it upside down, right?
Yeah.
That's just 1 plus b bar. Yeah?
Oh,
Because
so it's 1 on that, which is.
so 1 plus b bar.
It's just
Why is it
Um,
1 plus B plus B?
Huh?
the reciprocal of that.
it's 1 over that, but like the point is there's 2 points, I guess. One of the points is that that's just f, okay?
Yeah.
Yeah. 1 plus b bar is f, yeah?
Yeah.
Alright.
Yeah.
Yeah.
It's 1 on F, so it's the.
So this is 1
it's
plus b
conjugated
plus
like
b
that.
bar, yeah?
Mm.
Okay, and one other thing to notice is it's real, yes?
Yeah.
Because it's something plus b
Oh,
bar.
yeah, B plus B bar. It's real.
1 is real, b plus b bar is real, yeah?
Yep.
So what that's saying is
It's,
this
it's
is a multiple of the orthocenter,
Whoa, okay.
I see.
yeah? So
Yeah.
this is collinear, yes?
So, what, yeah, A, so F.
So,
Uh,
yeah?
yeah.
Okay.
Ah,
That's collinear.
when F is real as well.
F is real, 1 on F is real as well, yeah?
Yeah.
Yeah.
So,
Oh,
so
yeah.
the H is real times
Real.
OH, yeah?
Yeah.
So it's just a scalar of,
Oh, okay, yeah.
so they have to be collinear,
Yep.
yeah? Okay, I mean another thing that's I don't know if it's to be expected, but it's kind of it's symmetry. It's symmetry because OAF is collinear, right?
Yeah.
Is that obvious?
Yeah. Well, A and F are both real.
Yeah.
Yeah, that's true. And an orthocenter, and it's like symmetric, so it's in the
Yeah.
middle, right?
Yeah.
Okay. All right. I think we might need another diagram.
Do we have this collinear? OAF and
Oh, H
H
and the
is-
other H.
Yeah. And
alright.
yeah. And we kind of want to join the F and the H together, like to make a triangle, yeah? And then the
Yeah.
midpoint of that triangle is G. Well, the midpoint of the base of that triangle is G.
Okay.
Is that the diagram I want to draw?
This is like productivity drops after like the first 2 hours.
Yeah.
Yeah.
I need chocolate.
So that's like, oh, chocolate, good idea.
Yes! It's not dark.
I think-
No!
Wait,
Wait,
but
not,
chocolate isn't dark chocolate.
non-dark chocolate gives more energy.
It's more sugar.
It's also trash.
Never mind me, I just slept for 1 hour last night.
No.
Sometimes it's the idea that's the important thing.
Oh
The,
my
the
God.
execution is trivial.
Whoa!
We have a choice here: hazelnut,
Dark.
Hazelnut.
dark,
Hazelnut.
or dark.
Hazelnut.
Oh wait, there's dark salted caramel.
Hazelnut.
Just
Just all dark.
dark.
Alright, hazelnut plus dark.
Dark.
Okay, I can call one. What's this?
Hell is this?
Give me this one. I'll take this one. Fine. Don't matter. Ah,
How do I remember this?
72%. That's decent. Okay.
Not 96.
Bomb. Okay.
What's yours normally?
Alright, try to prevent. Okay, so one of your goals is to minimize carpet chocolate. Okay.
Alright, yeah.
Yeah, so just back inside now.
Breakfast. Alright. What that?
Oh, no. I wonder where that's from.
From Ghana.
Yeah, even Ghana.
Boom.
You wanna try?
I'll break it inside.
It's literally.
Yeah, just other way, other side.
What?
Which side do I break? I'll break the other.
Ah. That's just the wrapping.
Aren't you meant to break like this?
That's just the wrapping of the wrapping.
Exactly. I don't use this as to your advantage.
You want one hazelnut?
No.
Oh.
It's not great.
Hazelnut's good. Nuts are generally good,
Not as good as dark.
Nah,
but it could be dark like hazelnut.
hazelnut.
Dark hazelnut.
Dude, what the hell happens?
Yeah. Well, I always wonder, like, is it like better to get, because like obviously one of the ingredients is cheaper, so when they put them together, something's. But then the combination is more than the sum of the parts.
Sorry for sleeping. I only slept for like 2 hours last night, so yeah.
Ah, I see.
2 hours last night, never mind me. Yeah, I don't even know how I woke up this morning.
You know, like instead of having these lessons, you could actually just put a video recording of me while you sleep. It's pretty much the same.
Hazel?
Alright, okay. So the diagram I'm referring to looks something like this, okay?
Oh.
You have a triangle, yes? Yeah? This is the origin. This is the orthocenter of ADC. Yeah?
And then there's F.
And this is F, yeah? A goes somewhere here. And H goes somewhere here, yeah?
Yeah.
Yes?
Yeah.
And we can join that up. Do I want to join that up? No. The midpoint is G. Yeah? Okay. So what are we even trying to show you? So F. Okay, so F is trying to. So F goes to H, it gives you M, right? Yeah.
Yep.
And you want to show that A going through the same point gets the HADC. That would be that would conclude the problem,
Yeah.
right? Okay.
Is this a different problem?
So this, I must admit, is probably a tough step. And so I had a little bit of a hint for this, okay? And can you see that? So if I'd drawn the diagram better, I probably wouldn't have needed the hint. If you drew the diagram well, you might be able to see that AH is parallel to FH, ADC.
Parallel FH.
Okay, so first of all, can you see that if it was parallel, right? Okay,
Yeah.
so if this was parallel to this, yeah? Can you see then that that would have to go to, that would have to work if it was parallel?
The intersection's like OG, yeah. Right?
So basically what I'm saying is, if they're parallel, right?
Yeah.
And A goes through the intersection where F intersected OG, yeah? It would have to go meet at the other orthocenter. Okay?
Yeah.
The point is, because this, if they're parallel, then this is the midpoint, that's the midpoint too. Right? And there's like lots of similar triangles in there, yeah?
Yeah.
So basically, it meets somewhere, right? But you can show that that length has to equal that length. See what I'm saying?
Yeah.
So, and I think that's kind of like a common kind of problem when you have the two parallel lines,
Yeah.
like across, yeah?
Michael.
Oh, thanks.
Please don't notice that.
Okay,
I'll grab some water.
good idea.
And for more convenient purposes, also with.
Oh my gosh, it's an optimization of chocolate carpet. No, I'm just doubting you, sorry.
What?
No, he said reduce carpet chocolate. Which I'm pretty sure you did take further.
Do not understand.
Carpet chocolate.
Don't put the chocolate on the carpet.
I used the wrapper to my advantage.
Did you?
And so, yeah, we basically roasted. Hazelnut's amazing.
What?
Why does everyone prefer dark chocolate?
Dark is better.
I don't know. I don't know. Maybe it just
Hazelnut's
depends
like-
on personality.
Like it tastes better, but dark is probably better for you. Is that what you
Yeah.
reckon? It actually tastes better.
That's true.
I like the taste of dark better.
Maybe like when you're used to eating healthy food, healthier stuff just tastes better. I know for a fact that if you don't eat healthy food very often, like
Like I do.
your bar, like you can't like eat in certain foods. Like your bar for like fat and stuff is at
Yeah,
like
this is really
a certain point. Like when I was like playing lots of sport, I was trying to eat healthy, so I was like I could eat anything and it would kind of taste good. But then sometimes like after you don't do anything for a while and you kind of let yourself go a little bit, it's like for example, before when I was eating dark chocolate, right? I was like, oh wow, this is so sweet and tasty and stuff. And then after I started eating all this other junk food, it's like I'm eating this and I'm like, oh, it's not enough. I need like higher fat content, higher sugar content.
Hey. Apparently the person who lived the longest ate like a one piece of dark chocolate a day.
Okay.
Dark chocolate is actually good for you.
So I guess one thing to take from this, right, is that proving it's parallel is actually trivial in the complex batch setting.
Okay.
Okay? So how would you prove it's parallel? Okay, you just go h minus a,
Which one is one?
yeah?
You're seriously using
So you basically just got to calculate h minus a, yeah?
Okay.
Does that make sense?
Yeah.
Can I erase some stuff?
Yeah, you have to.
Probably like the bottom right.
Yeah.
Random.
Okay.
So the refugee and the Reggie.
Refugee.
The random thing.
Does dark chocolate genuinely taste better for you?
Yes. I like
Maybe it just depends on the person. But I would just better to read like dark chocolate, but not like it's.
Alright.
Maybe I could teach myself to get used to dark chocolate one day.
Okay. What are we doing again? Oh,
AH parallel to FH.
alright, let's do it. If we get stuck, we can look at what I wrote before. So what is h minus a, yeah?
H minus one.
Yeah, h minus, it's already, yeah, h minus 1.
Oh yeah, H is one.
That's like the simplest something.
H is. Is
Huh?
that a formula for
There's a
integer?
formula for H, isn't it?
Yeah, we have hate.
We have this, yeah, that's
Yeah,
this.
it's like the one, yeah.
Oh, is that
No.
that's H? Oh, it is. Yeah.
So bc plus b squared c plus b, right? On all this
Minus.
Yeah.
Minus
minus
3 squared.
1 minus b squared, yeah? Alright. Does anything cancel?
The B.
No.
B is.
Oh, it's something.
That's like literally it.
No, hold on. There's a 1 plus b that cancels too, right?
These things are pretty annoying.
Hmm.
If we can somehow get over the C, that'll be much better.
What are we trying to show? It's equal to f minus HADC, right?
Yeah.
What is f minus HADC?
It's 1 plus B bar. Balance, what's with ABC?
And what's H? That's
What did you say? 1 minus...
1 minus. Well, it's 1 plus B bar minus some stuff.
No, HADC is just H plus. It's just A plus D plus C, isn't it?
Because D is
Oh no, H is not the sum. It's just wait. What is it?
Isn't it the author sign?
Yeah. So it's the author center. It's this thing here. So it's A plus. So H we had what? We have. Oh, it's just the author center. It's not the midpoint.
Yeah, so it's A plus D
Yeah.
plus C.
A plus C plus D. Right?
Yeah. Or A plus C
isn't it
plus
just-
DC.
And then D is just
It should be just B plus E, isn't it? Oh no, B plus E minus. No. B plus B bar minus C minus D.
Yeah.
Yeah.
But you,
So the ones cancel. Yeah,
The
that's ones cancel, and then you get the B plus E
then the B cancels with the
minus the
minus.
C minus CD. Yeah.
Yeah.
That's what
Wait, CB.
CB.
Yeah.
Oh yes.
We can put stuff.
Okay.
We can put.
This is. Mhm.
Wow. Apparently it takes not as way more comfortable.
Nice.
I assume we're gonna take this for ourselves.
Yeah.
What?
Dark chocolate doesn't melt.
True, your thing is super hot.
Dark chocolate
Dude.
melts faster. doesn't it?
No, your thing is super hot. You should just feel hot.
Wait, that
Oh,
one
right,
is
never mind. Got it mixed blend.
like you put it in your mouth, it's still like solid dry of ages.
Alright, so this is b squared plus 1, right? Minus bc minus b squared c on b, yeah?
Yeah.
You see that? So just treating b bar as 1 over b, and then putting everything over b.
Yeah.
Why does this look a bit familiar?
Because
I
it's the
wonder
same
why.
as the top. So look at the top, okay?
The denominator
Okay,
is not the same.
so the denominators are not the same, but the numerators are like negatives of each other, right?
Yeah, true.
Yeah.
So bc minus bc, b squared c minus b squared c, minus 1 1 minus b squared,
I
right?
tried to prove that one's a multiple of the other.
Yeah. But look what the multiple is, it's f, right?
Oh.
Or 1 on f or whatever it is. It's
What something F.
because
F?
you times it by this over b, right?
Oh,
And you
yeah,
get
yeah.
that. Negative that over b. Yeah? And that's what f is, right?
Yeah, it's b plus b bar plus 1. Yeah.
Yeah.
Because 1 plus b squared divided by b is.
Oh yeah.
Okay. Yeah? So that shows it's parallel.
Yeah.
Okay?
And
That would solve the problem. Okay?
Nice.
Yeah, and I didn't stop here because like I was still being dumb and trying to bash the thing. You know, I was still bash. like,
once you show it's parallel, it's done because.
Oh yeah. Okay. So
So that triangle.
if they're parallel, right? So you know that like this is the midpoint of the two red lines, yeah, the two. Yeah. And then like this line goes and makes like a similar triangle
Okay.
there.
Yeah.
And so the ratio of this, whatever the length is here
It has to be same.
to that
Oh,
has
yes,
to be
that's
the ratio,
also
like
the
this
same.
to that, which is that to that, right?
Okay, yeah.
So then it's equal. So then the point it intersects is just h.
Okay.
Yeah. So yeah, it's kind of nice actually. It's a little bit disappointing that there was actually some geometry in there,
Oh no.
but like not disappointing from the point of view of the truth, I guess. Should stop this. Yeah, but there's other ways to continue the bash. If
Don't try some.
so, I want to kind of explain. There's another way to kind of continue the bash, right?
This,
So the point I want to make before my phone dies
What?
is, so one way to continue the bash, okay, is to show like
I don't know, it feels off.
it's much easier to figure out what m would have to be. Like it's much easier to figure out the intersection of OG and A orthocenter. Yeah? So for some reason when I did it, okay, so like, because M is the intersection of FH and OG, right? Yeah? But it has to, like for it to be true, it has to also be the intersection of A to the orthocenter and OG.
Yeah.
Yeah? So to find the point where the orthocenter line intersects OG is much easier.
Yeah.
Okay? So I could actually do it. Alright, so it was like, what was the formula? It was something like this. BC squared. And you'll also find like sometimes you just want to look at the answers on the art of problem solving, but no one does it by a complex bash. So you're just like, oh. It's like even when you admit defeat, it's like you can't. It's like b squared minus 1 plus cb minus c. Oh wait, no, this is the second last line. B squared minus 1. 1 plus b plus c.
Would you guys have given water? Because I don't have a water.
B plus 1.
No.
I say a cup square.
Yeah, probably called up for this.
Okay. So that will tell you what m has to be, okay? And so that kind of saves you from, because if you were doing it normally, right, what would you be normally doing? You'd be finding, you know, am something and then taking like a conjugate to show it's imaginary. You know what I mean? Because if something's perpendicular. So that's why, like, if something's perpendicular, it's that times by I, right?
Yeah.
Because it rotates by 90 degrees. Yeah, that's what I does. So to show that something is another thing times I, like you could take the ratio and it's equal to I something, right? And then take the conjugate, and then it has to be negative because I just goes to negative I.
Yeah.
So I don't know. It turns out kind of messy, but it's kind of easy to get a point like this. So I never quite tried this completely. I kind of didn't really have time. But if you put this as your m prime and try to show that m equals that, you'd at least get to the point where like you have lots of powers of b in two sides and you're just saying they're the same as each other. Okay? So I think that would be a promising way to go if you wanted to keep bashing it. Alright? But I still, like, even though I wanted to do it thoughtlessly, I think it's still more elegant to use actual geometry to solve the problem, right?
Yeah.
So it's just like, so if you do it like that, it's kind of like anytime you actually need something, it's there, that's right? You get the pieces mindlessly, you don't get the whole thing mindlessly.
Is that what you want to?
I don't know. Alright, I might stop that there.